This is the second part of a pair of videos about functions in C. The first part covered top-down design, structure charts, and how basic functions work. With this one, we'll cover how we pass information into a function and get results out of a function. This is the example program that we're working on. It's outputting an ASCII graph of the sine function. In the first video, we designed this structure chart and wrote the code for printing the heading of the graph. The goal of the next function we're working on is to print one line of the graph. Every line in our graph has some number of spaces followed by an asterisk, so our printLine function is going to need to be told how many spaces to output, but it doesn't require any other relevant data. The result of this function is to output the right number of spaces followed by an asterisk and a carriage return. My strategy for building this is to have a loop that goes the given number of times, outputting one space each time. Then output an asterisk and a carriage return. Testing this is a little tougher because we need to make sure that it works for a variety of inputs. The easiest thing I could think of for this is to make the main function call printLine a few times, giving it increasing numbers for how many spaces it should output. If that works, we should see a line like this as the output of main. Here's the code that strategy gives us. In the declaration of printLine, notice this int height in parentheses. That looks like and is the declaration of a variable. When we put it in the method declaration like this, it's saying everyone who calls printLine has to give a value that will be stored into height. That variable is called the parameter of the function. Inside the function, we can use it like any other variable. Here, we're using it to stop the loop. If this for statement doesn't look familiar, don't worry, we'll talk about them soon. Suffice it to say that this loop makes the stuff in the curly brackets happen height number of times. Now, let's look at how we're using printLine in our main function. Like before, I call the function by using its name followed by parentheses. However, this time, I put a value inside those parentheses. That is the value that I want to put into height for each of the calls. That value is called the argument, and putting it there essentially tells the machine, store this value into height, and then execute the code in printLine. So the first time we call printLine, it should output 0 spaces. The second time, it should output 5 spaces, and so on. When we run that, we'll see the slanted line that we were hoping for. So just to review, height is the parameter in printLine, and every time we call printLine, we have to put a value into the function call. That value is the argument to printLine, and that value will be stored into height. Our printLine function only required one value of input, but we can make functions that have more than one parameter. For example, there is a PAL function in math.h that is declared like this. It has two parameters, x and y, that are both ints. It is defined to return the value of x raised to the yth power. When we need to pass more than one value into a function because it has more than one parameter, we put the arguments in a comma-separated list in the parens of our call on the function. For example, if we called PAL passing 3, 2, the 3 would be stored in x, and the 2 would be stored in y, and PAL would return 3 squared, which is 9. Two things built and tested. The next thing we can build is a function that calculates the number of spaces for a given sine value. Here is our specification for this new function. You should pause the video and read all of this. There is one thing that is subtle but very different here. Until now, the results of a function have always been something that was output to the screen. Here, instead of saying output, I said returned. That means that we're calculating something and giving that value back to the code that called the function. Let's look at that more carefully. Here's our code. Our relevant data is in some pound defines, so we know the range of possible values and how wide the graph should be. Calculate spaces is declared to have one parameter, its one input, named x, and we will pass in a value between -1 and 1. The function should figure out how many spaces we need to represent x in our graph. Before we look more at calculate spaces, let's look at the code I'm using to make sure it works. Since it has one parameter, and my testing strategy said I should verify that it works when I give it 0, -1, and 1, I'm just printing what I'm hoping for and what happens when I call it passing in those values. So the question is, how does information get back from calculate spaces to where we call it in main? If we look at the declaration of calculate spaces, it starts with a type. That says it's going to give back an int. And the magic for how it gives it back is in this return statement. Every function is declared like this. It has a return type, a name, and then a parameter list in parentheses. If it doesn't return anything, its return type is void, which is what the return types for print heading and print line were. So the first part of making a function return a value is to specify the type of that value in the function's declaration. The return statement is the code for how we specify the value that should be given back to the caller of the function. The return statement does two things. It stops the execution of the function, so the machine will jump back to where the function was called, and the top stack frame will be deleted just like before. The return statement also specifies the value that the call on the function should evaluate to. To clarify that last part, let's look at our code one more time. Calculate spaces is doing some magic math to calculate the number of blanks that is appropriate for the x it is given. For this video, I don't really care how that works. Instead, I want to focus on this statement. In the definition of this statement, I said it specifies the value that the call on the function should evaluate to. So, that means the call should evaluate to the result of rounding num blanks. So, when I call it with -1, x will be -1. The magic math will make num blanks be 0. When the return statement executes, the call on the function will evaluate to 0. That means our printf statement will print out 0. So, when we're building a function that has returns in its results, we have to make the return type specify the type of value it will return, and we use a return statement to specify the value it should give back. When the return statement executes, it's giving information back to the caller, and that information will be what the call evaluates to. We've built and tested 3 of our functions. The last thing we need is printgraph. It will have no parameters. Its return type will be void because it's just outputting something to the screen. And we'll test it just by calling it from main and watching it work. For completeness, here is the code for printgraph. It uses math.h to get the value of the sign function, calculates the number of spaces needed for that value, and prints a line for that value. All of that is in a loop that varies the variable angle from -pi to +pi. Now we've built all of our functions. We just need to call the top 2 functions from main and we're finished. Well, except for a few little details. The compiler reads your .c file from top to bottom and needs to know what a function looks like before it can translate calls on that function. So every function has to be declared above where it is used in the file. We used structure charts and top-down design to plan what we wanted to build, and then we built and tested functions one at a time. That helped us build code in little pieces, which made it much easier to debug than writing all of the code and then trying to make it work. Finally, understanding how the call stack works is really critical to understanding how your code works. Click the link at the top of the screen if you'd like to see a video that goes into that in more detail.